Hello, this is tutorial on 2.1A1. A little note up here, you'll be working with some negative numbers here and with absolute values, and these are 7th grade targets. You're not going to be tested on the negative numbers, but it's just good to have a look at all of them. So 15 degrees Celsius below zero. How would we write this? We just write this as minus 15. It's one of those weird things where we're just writing an integer for the situation. We don't need to include the label. So a profit of $27, this is just going to be a positive 27. Again, no label on this. 2010 AD, this is just 2010. Whoops, I did that wrong. Not 210, 2010. Which shows you how old this book is. Let's see if we can find a BC one on here. Doesn't look like they have a BC one. That would be, oh, here it is, 240 BC. This is going to be a minus 240 because that's before the year of zero. Here's year zero, and here's BC. BC is over here, and this is AD. Going this way. These numbers are getting bigger going this way. These numbers are getting bigger or more negative going this way. 60 feet below sea level, this is going to be a minus 60 because you're below sea level. A deposit of $41, this is going to be $41. A withdrawal of $200, this is going to be minus 200 because you're taking that money out. If the attendance is down 38 people, this is going to be minus 38, and so on. I'll leave you a few to do on your own. Let's take a look at the bottom of this page, which gives you kind of a neat little lesson on absolute value. Absolute value used to confuse me as a kid, and nobody ever explained it to me, that absolute value is simply the distance from zero. So let's take a look at this number line right here. We're just going to make it very simple. We'll put a 0, we'll put a 1, a 2, we'll put a negative 1, and a negative 2. All right, now the absolute value of negative 1 is 1 because it's one spot from 0. That's what the distance is. Now, here's draw some problems over here. The absolute value of 1 is also equal to 1. So it's always going to be positive because we always measure distance in a positive number. So the absolute value of 9 is just 9. The absolute value of 23 is just 23. And 107, what do you think it's going to be? Sorry, negative 107. It's just going to be 107. So when we take it out of those absolute value bars, it becomes positive. So let's take a look down here and see what we would do with number 20 then. Well, when this comes out of the absolute value bars, it's just going to be a positive 6. When this one comes out, it's going to be a positive 2. We do the brackets first. Oh, did I say brackets? The bars, but we treat them just like brackets or parentheses. We do what's inside them. So this becomes 6. This becomes a positive 2. 6 minus 2 is 4. Think about this one for a second. Now, 6 minus 7, that's inside the absolute value bars. So if you had $6 and you spent 7, you'd have a negative $1. That would still be inside those absolute value bars because you do what's inside them. First, you treat them like parentheses or brackets. Then the absolute value of that is 1. Here's one that's really crazy. It blows my mind. Absolute value of negative 3, and we're going to compare it to the absolute value of 2. Now, is that less than, greater, or equal to? Well, you have to do the absolute value of it. You might say, how can a negative number be greater than a positive number? Well, it's not a negative number, it's the absolute value of that negative number. So the absolute value of 3, negative 3 is 3, and the absolute value of 2 is 2. So in this case, it is greater. Graph each set of integers on the line below. That's just real simple, some graphing. All you do when you graph is just plotting points on the line. Okay, but you can see when I've plotted those, the absolute value of -3, well, it's 1, 2, 3. The absolute value of 2 is 2. Okay? All right, I'll leave you a few of those to try on your own. Just a little 7th grade enrichment. Thanks.